Okay, so we will let square root negative 1. Okay, we will let the I be defined as square root of negative 1. Okay, so this is the definition. I is defined as a square root of negative 1. So after that, actually, it becomes life becomes easier. So you have an example. Let's say if you deal with something like maybe square root of negative 4. Okay, then I can actually write this as a square root of 4, square root of negative 1. This is based on your understanding of surds, right? Square root AB is square root A times square root B. And then this is just 2. Then this portion will just give you I. Okay, so far? Can, huh? Can, right? So very easy. Okay. So first one, we have answered the first question. How is a complex number defined? And how do we write a complex number in a Cartesian form? So we actually go on to it later. Alright? So for the first definition, let me just quickly show you. The imaginary number I is a number such that I squared equals to negative 1. Okay, and square root of negative 1 will be equals to I. Okay, so I is an imaginary, what we call imaginary unit. It's an imaginary unit. Okay, so however, you have done, example, you've done solving of quadratic equation. Sometimes, am I right to say, sometimes your answers can look example, x equals to negative 4 plus minus square root negative 4 over 2. Okay, then you see you have negative 2 plus minus 2i over 2. Am I right? And then you can have things like negative 2 plus minus I. Am I right? Because you cancel off the 2. This is from, who said ha? Is someone ha? No ha. Ha later I ha you back. Okay, so this negative 2 plus I. So it now makes us to think, actually, in the complex number, there's also a real part. There's a part that is real. There's also a part that could be imaginary. Alright? So when you still have a number that has both real and imaginary part, we call this a complex number. Okay? So a complex number, usually in Cartesian, so far in secondary school, we always use x, we always use y. By convention, complex numbers, right? Okay, so this, we always use z or z. We always use z. Okay, so you see that we always use z, means z actually refers to a complex number. Okay, by convention. Okay, it's an element of, this symbol represents the set of complex numbers. Okay, this will be the same as we have studied natural numbers, integers, rational, real numbers in the past, right? Now the next set of numbers that you encounter is the complex numbers. Okay, yeah, okay. Don't sleep, okay. So with that, this is the definition of complex number. I see the number of the form x plus iy. Okay, if you read your comprehensive notes, okay, so you remember, if we define z equals to x plus iy. Okay, x is what we call, okay, most importantly you must know that x and y, okay, this is what we call the imaginary part. If my handwriting is too ugly, just correct me. Okay, this is what we call the real part. Okay, this is what we call the real part. Okay, so and again, x is defined by so-called the real part of z, and y is what we call the imaginary part of z. Alright, so remember, the imaginary part of z is y. Okay, common mistake is people will go and put iy. Okay, the imaginary part is not iy, okay, it's actually just y, the imaginary part. Okay, so actually your imaginary and real parts, they are actually real numbers. Most importantly, you must know. Okay, x plus iy, these two has to be real numbers. They have to be real numbers. Okay, alright. Okay, very quickly, so this is, again, this is from your lecture notes, the comprehensive notes. Okay, I just put it here to give you a gentle reminder, okay, that you should have seen this before. Okay, this is not your lecture question. Okay, this is from lecture notes. Okay, children? Can all? Yeah. Today, if someone sleep, I'll ask the person on the left and right to stand up at the back. Okay. 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 This is SAS style. Okay. 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 So question one very easy. Okay, so I'm sure you know. Okay. So given complex numbers, we need to write the real and the imaginary part. Okay. So again, ingrained in your mind now. Okay. You are introduced to a new type of number, complex number. Usually we use z. right? Where z is a part of a complex number, alright? And x plus iy are real. So this is what we call real part. So very quickly, 3 plus I, you can see, okay, the real part is 3. Imaginary part is 1, not I. Okay, who say I? Okay, it's 1. Okay, can hold. How about this? What is the real part? It's just 0. Imaginary part, -2. Easy, right? So easy, right? Wow, so unbelievable. Okay, so real part is just, how about D? Real part is just -6. Imaginary part is just I. 1. Thank you. So, okay, 1. Okay, done. Okay, so this one. Okay, so if you look at, again, if you look at part B and part C, okay, you notice that for part B, right, okay, it is what there's no real part. Okay, so this is, again, if you read your, so I always try to advertise the comprehensive notes, you must go and read. This is what we call a purely imaginary number. Okay, this is what we call a purely imaginary number. Alright, how about 7? 7 is what we call it's just a real number. Right, just real. Don't you see, just real number. Okay, Okay, question 2. Okay, before question 2, we just want to stress on one portion. That's what we call the equality of complex numbers. Okay, unlike your so on equality of complex numbers, remember that your complex numbers now you're dealing with two parts. One is the real part, one is the imaginary part. And how do we compare two complex numbers? Is that we have to compare both the imaginary part and both the real part. Okay, so again, this is from your comprehensive notes or your lecture notes. Okay, the full notes. It is not in the lecture question, I believe. Okay, two complex numbers are equal if and only if there are two conditions. Number 1, okay, so let's say if I give you the first complex number, second complex number. Okay, what we do is, in order for us to equate the both of them, okay, number 1, what do? We have to equate the real part. Okay, that is, you have to make sure the real of Z1 is equal to the real of Z2. Okay, number 2, we have to equate the imaginary part. Okay, so I use another thing. Okay, so you must make sure that Y1 is equal to Y2. You have to make sure that the imaginary part is equal. Okay, these are the two things that we have to ensure. Okay, and I also one very important thing, you must make sure, okay, your X and Y, in your complex numbers, your X and Y are real. Okay, your X and Y are real. Okay, so for example, if I give you something like this, maybe I give you Z1 plus I of Z2, where Z1, Z2 are complex numbers. Okay, maybe let me call this Z3. Okay, can I say that the real part of Z3 is equal to Z1? Can I say this? Very good, you all see your head. Okay, so you all next one. Why? Because Z1 is this real? Is it real? Yes? No? No. Okay, so because you can say this actually is a complex number. So, lesson learned, you forget everything I say, don't sleep. Okay, remember, X and Y must be real. Okay, your real and imaginary parts of complex number must be real. Okay, so if there's one thing I want to point out to you, is this portion. Okay, is this portion. Okay, especially when you are doing your question 3, it will help you. Okay, can. Okay, with that, you can look at question 2. I'll just give you 3 minutes. Okay, when the time becomes 12 minutes, I will stop. Okay. Maybe I pause. Okay, so with that, right, you can see that, okay, so if I want the two numbers to be equal, okay, let me erase this whole portion. If I want these two numbers to be equal, I need to equate the real portion, the real part, and the imaginary part. Okay, so some of you are not clear. Okay, so after that, what do I do? Very simple. Okay, I need to equate x plus 2y. So observe, right? I need to equate these two. Am I right? And second portion, I need to equate these two. Okay, huh? Okay, huh? And am I assured? Can I just check with you? Do you know? Is this assumed to be real? Is it real? Yes, right? Because x and y are real. Is 3 real? Yes, okay. You see, I will keep nagging you about the real part. You must make sure that it's real. Negative x, is it real? Yes, right. 2x minus y, is it real? Yes, right. Okay, very good. Then, now we are ready. Okay, so maybe what we can do is now, very quickly, we equate the real parts. Okay, then we have just this portion, okay, x plus 2y on the left hand side. On the right hand side, remember just now it's just negative x, right? This is equating the real parts, right? So from here, you just get x plus y equals to 0. Let's can call this equation 1. Now this becomes a very nice and friendly simultaneous equation. So now we equate the imaginary parts. Okay, then you have 3. 3 is on the left hand side. On the right hand side, you have 2x minus y. Okay, and solving both, okay, I believe you can solve by yourself by using GC or using algebra. You get x equals to 1, y equals to negative 1. Okay, can all. And all these are from nothing but a simple concept that's equating complex numbers. Okay, equating the real and imaginary part. So let's look at what our friends did. Okay, I think this is from in E, 2M, A, 2B. Okay, can you see? Right, equating the, okay. So actually maybe no need this. Maybe it's only this. Okay. Sorry. Okay, but other than that, it's perfect. Okay, so you see, anybody, I just blindly pick one person, she can do it. Also means you all are very smart. Okay. This is from y equals to negative 1. Y equals to negative 1. X equals to 1 as well. This is from Yap Jia An, correct? Okay. So 2MA, 2K. Okay, done. So question 3. Okay, question 3 again, very quickly, 3 minutes. Okay, tell me what is wrong. Okay, pinpoint what is wrong. Okay, after that, try to find the correct solution. Okay, try to find the correct solution. Okay, if you are able, okay, just to give you a heads up, if you are able to do this correctly, the correct value of x will be negative 1. Okay, the correct value of x will be negative 1. Okay, so 3 minutes again, try this quickly. Okay, very quickly, okay, what is the mistake here? Remember just now, there's one part I will keep nagging you, right? We want to compare equality. What's the first condition? Both sides have to be the parts have to be real. Okay, so in this case, now this student assume very quickly, this looks like the real part. This looks like the imaginary part. This looks like the real part. This looks like the imaginary part. Am I right to say so? Cannot, right? Because z is a complex number, it's not real. So straight away, this is wrong. Okay, this is also wrong. So with that, you get a wrong answer. Okay, so that's the mistake. Okay, you always emphasize that equality means that both the real and imaginary parts have to be real. Okay, x plus iy, x and y have to be real. So what is the correct solution? Okay, very quickly, if I were to take 2x plus I z, right? This is the same as 2x plus I x plus iy. Okay? On the right hand side, remember just now we had z minus I x plus 1. Okay? All we do is, again, we know that from the question z equals to x plus iy. Alright? So what do we do? It's just x plus iy. I replace z with x plus iy minus. If you don't catch it, it's okay. I'm recording, so I'll send this to you. Okay, so it's ix minus I. Okay, because you are distributing the I inside. Okay, with that, I regroup. Now that you can see my real and imaginary parts are all over the place, what I do is I start to group my real parts together. And you can see now I'm grouping my real parts, which is just x. My imaginary parts is just, okay, so over here. On my left hand side, what is I square? I square is just -1. Okay? Remember just now we defined I as square root of -1. I square is just equals to -1. Side note, so from here, I square y actually just becomes -y. Okay? On the right hand side, okay, all I do is I look at these three terms, I factorize out I. And you can see quickly that this is the, now, given that x and y are real, okay, you really have the imaginary part, you really have the real part, you really have the, okay, sorry, this one let me regroup again, let me rewrite this. This should be 2x minus y plus ix, okay, you really have the imaginary part, you really have the real part. Okay, so I need to emphasize you, when we compare the complex numbers, the components, the members must be real. Okay, so very quickly, if I compare these two, I compare 2x minus y, x. Okay, first one, comparing the real parts. Okay, 2x minus y equals to x. Very quickly, you can also assume that this just means x equals to y. Comparing imaginary parts on both sides. Okay, x, y minus x minus 1. Okay, it just implies that 2x equals to y minus 1. Okay, so very quickly, equation 1, equation 2. All you need to do is just sincerely just solve the equation. Set 2 math, okay? And then just these two will give you, solving it, you will just get x equals to -1. Okay? Easy? Okay, actually the execution part is very easy. The only concept you must know is that, okay, sorry to keep lagging, your components must be real. Okay? X plus iy, x and y has to be real. Okay? Can I go on? Yes, okay. Very comfortable, right? It's a very nice topic. Okay, so again, this is the solution. Okay, I need to emphasize that it's real. Okay. Okay, key questions to answer. This is for part 2. Okay. How do we carry out arithmetic operations? Okay, addition, subtraction, multiplication, division, taking out square root. Again, if you have read the lecture question, okay, actually it's just, this is again from your lecture notes. Okay, so I'm just telling this to you, that reading your lecture notes must pay off. You must read the notes. Okay, first one, addition of addition. Okay, this is addition. Okay, this is addition. Okay, given that your z1, okay, sub y is just x1 plus iy1. Shut up. Okay, z2 is just x2 plus iy2. The boys like to talk to girls, can you resist? Okay. After the lecture, then you talk. Okay. So this is your Z1, this is your Z2. What we do is we just add the real parts and the imaginary parts. That's all. Very simple. It's just that you are multitasking. You are adding a real imaginary. Okay. So let's say if you are not clear or you don't like to listen to my voice, let me just draw it for you. Basically, I just add the real part. I add these two. Okay. I use another color. Okay, so which color do you like? Okay, maybe equal house. Okay, so I use y1, y2. I add the imaginary part. Okay? That's all. Similarly for subtraction. Z1 minus Z2, you just, okay, you see that I just subtract the real parts. Okay, I just subtract again the imaginary parts. Okay, easy, right? Super easy, easy lemon squeezy. Okay, so after that, next one, what about if we multiply with a scalar? Okay, where k is a real number. Example, maybe 2 of z1, something like that. Okay, so k is a scalar. So again, k is just a constant. We can multiply easily. Okay, so we just multiply to the real part. Okay, again, k multiplies to the imaginary part. Okay, and that's your answer. So for scalar multiplication, it's just easy. Just bring in the scalar, that's all. Just distribute the scalar in where it has to be a real number. Alright, k has to be a real number again. How about if we are doing multiplication of complex numbers? Okay, what we need to do is we have to expand. Okay, it's the best. They write it as a sum of its own components, the real and imaginary parts. Okay, again, then from here, it's just like you can your elbow, don't put your chin, very likely you will fall asleep. Okay. 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 You're falling asleep, okay. Who's the girl beside you? You're falling asleep, okay. Warning 1, can you sit up straight? Can you're very muscular, so sit properly. Okay, so let people see your big frame, okay? The 2 television here, okay. You should be holding your pen, okay? Yeah. Body language is quite important. Okay, so x1 and x2. So all you do is just distribute. Okay, remember in the past you have learned this, right? A plus B, C plus D. Okay? Can if you are falling asleep, just admit. Okay, don't say I'm taking long blinks. Then you're not taking long blinks. Okay, so okay. X1, X2. Okay, that's all. X1, X2. Distribute x1, IY2, x1, IY2. x1, IY2. Okay? Next portion, IY1 to x2. IY1 to x2. Okay? Last portion, you can see that IY1, IY2. IY1 and IY2, that will give you I squared. What is I squared? I squared is just negative 1. You see, right? So you can see I squared is just negative 1. So from here, you can see that, children, if you observe carefully, this will be your real parts. Correct? Because I squared is just negative 1. So x1, x2 minus y2. This will give you the imaginary part. Okay, so for multiplication of complex numbers, you just multiply them distributively. Okay? How about for division? Division, very quickly, I'll give you a while to observe. What we do is saliva. Okay, so we just take the what we call conjugates. Okay, so conjugates, where have you heard the word conjugate before? Bio. Math. Surds, right? Remember surds? Right, so if I give you example A plus square root B, the surd conjugate is A minus square root B, something like that, right? So conjugate meaning, what we do is if let's say you see x2 plus iy2, how do we do this? Let's say if I just ask you to look at this, right? How do we do this division? Basically, just like surds, right? We multiply, we take the denominator. Listen carefully, okay, we take the denominator and observe that it IY2. Okay, so you multiply by the conjugate of the denominator. X2 minus, this is plus, right? So it becomes a minus IY2. X2 minus IY2. Okay, so what we do again, I'll back again. We take the conjugate of the denominator. We multiply by it. X2 minus IY2. X2 minus IY2. With that, right, you can see that actually your denominator x2 plus iy2 multiplied by x2 minus iy2, right? It gives you a very nice purely real number. Okay, because again, if you can't remember this is from what we learned in the past. A plus b, a minus b. What is this? It's just a squared minus b squared, right? So what is a squared? A squared is just x2 squared. What is b squared? B squared is like minus iy2 squared. Okay, so it's the same as x2 squared minus I squared y2 squared. Minus I2 squared. I power 2 is just negative 1. So it's just x2 squared minus negative 1 y2 squared. So these two will give you the plus. That's why you can have this as your denominator. Okay? Can all? Go very slow, but make sure you all can understand. Don't fall asleep. Okay? For the numerator portion, we just again this to this, right? We do the your so-called your FOIL method your FOIL method, just distribute. Okay, and you get this portion. That's how you do division for complex numbers. Okay, that's how you do division. So you cannot say you don't know. I've taught you it. Okay. If you cannot remember, go back take the video, watch 1,000 times. Okay, with that, right? Just help me quickly look at parts C and D. 2 minutes. I go on. Okay, question 5. Very quickly, I just need to try this question. I may not have time to go through, but the next 2 minutes, can I quickly ask you to try this question? This is a very simple simultaneous equation. Okay, so I just need you, P and Q are complex. This is just, you can call this a simple strategy. Equation 1, equation 2. Maybe you make P the subject or Q the subject. Okay? Then you call it equation 3. After that you sub 3 into 1 or let's say if you use 1 or 2, just use the other one. Okay? And then you might end up with a quadratic equation, and then you just try to solve the quadratic equation. So example, let's say you maybe end up with something like this. Maybe something P squared, P plus a constant, right, equals to 0. Okay, you should have a quadratic, you get a quadratic equation. Okay, and you try to solve. Okay, using a quadratic formula or whatsoever method you prefer. Okay, can I'll quickly just quickly try it. This one is not difficult, just treat it as a simultaneous equation. Make one of them the subject. Okay, you get this is non-linear simultaneous. So make one of the subject, sum with the other one, you get a quadratic equation. Then you just solve. Okay, quickly, 1 minute to try. All of you are bending your head down to do very good. I really like the effort. Keep it up.